Hi guys, hope you had a great weekend. We are back hitting geometry full force and with a new chapter. So this is actually our last chapter ever for all of geometry. It's crazy how fast time kind of went by. But this chapter we're going to be talking about all the shapes that we haven't talked about yet in geometry. So if you remember, we started by talking about points, lines, planes, and rays, and then we kind of moved into triangles. We talked about triangles for a couple chapters. And then last chapter, we talked about circles. This chapter, we're going to talk about polygons. So this might be a new term, a term that you might not have heard of, may never have heard of, but we're going to go over it. We have a couple notes that's just breezing through some definitions and a formula. And then from there, we're going to get into some practice that looks just like the IXL. So let's get started. So we're talking about interior angles of polygons. In order to discuss the angles of polygons, we first have to know what a polygon is. So a polygon is a shape with at least 3 and often more straight sides and angles. So it's just a shape that has at least 3 sides because you need 3 sides to create a shape. So some basic examples of polygons would be a triangle. I can also say that a square would be a polygon, right? Square, I could say a rectangle, which is in the same family as square. Those are both quadrilaterals. They have 4 sides. I could also say a pentagon. I could say the hexagon. Bunch of examples. So it's really just any shape that comes to mind. So those are all polygons. Now, we can further define polygons within certain scenarios. So when I say a regular polygon is when a polygon in which all sides and all angles are congruent. So we did talk about this a very, very long time ago when we talked about the equilateral triangle. So that is an example of a regular polygon. So an equilateral triangle is a regular polygon because all the sides are the same and all the angles are the same. All right. And then we can also split polygons into smaller shapes within each other. And we could do that by creating diagonals. So a diagonal is a segment that goes from one corner to another. So a good example is if I draw this rectangle, right? I can create a diagonal by going from this corner, I just picked the first one, to this corner. That would then give me 2 new shapes. It would give me 2 triangles. So the big thing with diagonals is you're always starting in the same corner when you create it. I can't go from this corner to this corner because that's an edge. I can't go from this corner to this corner because that's an edge. I can only go straight across. So it only splits it into 2 shapes. That's something to kind of keep on the back burner. IXL will ask you about that. That's why I wanted to introduce it now. So if you remember, when we had triangles, all the angles in a triangle added up to 180 degrees, right? So there's actually a formula that can be used to find the total sum of interior angles for any size polygon. So I could have a polygon with 100 sides, and I could figure out what that sum of the interior angles would be. So it says if n represents the number of sides of a polygon, then the sum of the interior angles, s, can be found using the formula. And this is our formula. So we can find s by subtracting 2 from the number of sides and then multiplying that by 180. And that will give me my sum. So today is very formula heavy. This is one of the key formulas that you'll need to solve the problems below and the problems in the IXL. And then we can talk about one single interior angle for a regular polygon. Because remember, a regular polygon, all the sides and all the angles are congruent. So I can find that one angle. And in order to find that, I have to take the sum and divide it by the number of sides. So you're taking the total sum and then you're dividing it by the number of sides. That gives you the interior angle for a regular polygon. All right, so we're going to use these formulas to complete a couple of examples below. I went through IXL, I found every example type that they have, and then we're going to go through all of them. So the first type that you could see, so it says directions. Determine the number of triangles formed by drawing all diagonals from a single vertex for each polygon below. So there's two ways that you can do this. You can physically draw the diagonals like I did for this square up here, or you can use a part of the formula. So I'll show you how to draw first. So the first thing you have to do is pick one vertex. It doesn't matter which one, but just pick one and you'll use that the whole time. For whatever reason, I like the top left one, so I'm going to pick that. Now I want to draw diagonals to all of the other corners that I can without going across the edge. So if you see this first line here, I can't do this because that would be going across the edge. So that's not what I'm looking for. So I can go to this corner, I can go to this corner, and I can go to this corner. That's it. That gives me 1, 2, 3, 4 triangles. So this shape can be broken up into 4 triangles. So that's one way that you can do it. You can physically draw it. I know you won't be able to draw on your computer screen, but you could like draw it on a separate sheet of paper or just count and go from there. The other way that you can do it is you can find the number of sides. So let's try to find the number of sides, or n. So this is 1, 2, 3, 4, 5, 6. So this has 6 sides. If we just use this first part of our sum formula right here, this will give us the number of triangles. So if I just take the number of sides and subtract 2, that gives me 4. That's another way that I can find the number of triangles in a shape. All right, so it doesn't matter how. You just have to pick one, stick with it. And let's look at the second one. Second one, same thing. So I'm just going to pick this vertex and I'm going to draw a diagonal. So again, I can't go here. That doesn't work. That's an edge. But I can go to this corner. And then again, I can't go here because that's another edge. So I can only draw one diagonal here. And that splits this shape into 2 triangles. And then, similarly, if I wanted to use that part of the formula, again, you don't have to do both. Just pick whichever one feels the best for you. It's 1, 2, 3, 4. So my n is 4. If I subtract 2 from my number of sides, that gives me the number of triangles, which is 2. So you don't have to do both, but pick one, whichever one you feel like works best for you. And that's how you answered that question type. So another question type would be using the full formula. So finding the sum of the interior angles of the polygon. So I'm going to write the formula at the top so we have it. So S equals n minus 2 times 180. So this is very rote. It just involves using the same formula over and over again. Most important thing is you have to subtract 2 before you multiply by 180. That's probably the biggest mistake that can be made. So we want to find the sum of the interior angles. In order to do that, we first have to find n. So step 1 would be to find n. And we do that by counting. So this would be 1 side, 2 sides, 3 sides. We know it's a triangle, but just for our purposes, we'll count. So I know that n equals 3. My second step would be to plug in and solve. Put it all in one. So I can take 3 for n and substitute it into my formula. And I have 3 minus 2 times 180. Then dealing with just, get the highlighter, dealing with this first. Remember, order of operations, we have to deal with the parentheses first before we can multiply. So 3 minus 2 is 1. 1 times 180 would give me 180. So my answer is 180 degrees. And you should know this by now. We went through so many chapters in the triangle section. So you should know that the triangle adds up to 180. That would be an easy answer. You wouldn't even have to do any work. But for our purposes, I'm going to show the work. All right, number 4. Same thing. We're going to start by finding n. Let's change the color. I'm getting a little sick of the purple. So we want to find n. So let's count. 1, 2, 3, 4, 5, 6, 7, 8. It says 8 sides, so my n is 8. Second step, we want to plug in. So S equals 8 minus 2 times 180. 8 minus 2 is 6 times 180 gives me 1080. So this shape, the sum of the interior angles, would be 1080 degrees. 2 more examples like this, so we'll move through those quickly. First, I want to find how many sides it has. So starting wherever, I'm just going to count around the shape. So just remember to make sure that you're starting and stopping at the same point. That would be the only major mistake that could be made. So this has 9 sides, n equals 9. And I want to plug it in. S equals 9 minus 2 times 180. That's 7 times 180. And that gives me 1,260. So this shape adds up to, all the angles add up to 1,260 degrees. And then same for the last one. And figuring this out, this has 4 sides. Plugging in, I have 4 minus 2 times 180, which is 2 times 180, which gives me 360. So this shape, all the interior angles add to 360 degrees. So that's the second type that you could be asked. Then the third type, so this talks about the regular polygons. We want to find the value of x, which is one of those angles. Whenever it gives you a regular polygon, remember you're doing the sum divided by the number of sides. So my first 2 steps are still the same. So the first thing I'm doing is finding n. So that would be 1, 2, 3, 4. So my n is 4. My second step is still plug in and solve. So that would give me s equals 4 minus 2 times 180. We just did this one. 2 times 180, which equals 360. Now my third step is to divide. We're doing s over n. So I know that my s is 360. So I'm doing 360 over my n, which is 4. 360 divided by 4 is 90. So x is 90 degrees. So it's just one extra step here. You're using the same formula, you're just dividing by n. The biggest mistake that people would make is to stop here at 360 and plug in 360. So you just have to make sure you're reading the answer or the directions very carefully. All right, let me make this a little bit smaller. That was a little too big for me. And let's try this one. So there are how many sides to this guy? 7 sides. So I know that my n equals 7. I can take that 7 and plug it in for n in my formula for the sum of interior angles, because I have to do that first. Then I get 5 times 180. I can use my calculator. 5 times 180 gives me 900. Then I need to do s over n. So that would be 900 over 7. Well, when I evaluate 900 over 7, that gives me 128.57, and so on. IXL wants you to round to the nearest tenth. This is a 7, so it's going to round the 5 up. So I'm going to wind up with 128.6 degrees. So this is the next step. So first we started with just the n minus 2 when we were looking at these examples. So when they ask you for triangles, that's nice and simple. It's just that n minus 2. Then we moved into finding the total sum of the interior angles, which involved multiplying that n minus 2 times 180, like 3 through 6. Then we took that a step further, and when we were given regular polygons, we had to find the value of x. So we took that n minus 2 times 180 and divided it by n. Now, our last step is going to be more along the lines of the second grouping with the s equals n minus 2 times 180, but we're going to throw in some algebra. So you want to solve for the variable indicated here. So number 9 says, what is the value of t? So I want to know the value of t. So remember, here we're talking about the sum of angles. So I know the sum of the interior angles can be found by using this formula. Well, if I know the sum, then I would know what this plus this plus this plus this would add to, right? So the first thing you want to do here is use the formula. So I know that this has 1, 2, 3, 4 sides. Now, they're only going to give you so many shapes. You might start to pick up on what the total degrees are. So I picked up on it. I know what it is, but I'm still going to go through the steps for you. So I know that my n is 4. If at this point you figured out what the total is, you can just move on to my next step. If you don't know the total angles, that's okay. That's what the formula is for. You can plug it in. 2 times 180, and that gives me 360. So I know that all of these angles add to 360 degrees. So we did something similar with circles. We did something similar with triangles. What we're going to do is add every angle that we're given and set it equal to 360 degrees, because that's what they all should add to based on this formula. So I'm going to add 32 plus t plus 83 plus 101. And that should equal 360. And then my next step, I want to combine like terms. So I have, should be a highlighter. There we go. I have 32, 83, and 101. Those like terms can be combined. So if I do 32 plus 83 plus 101, that gives me 216. So I get 216. Have to bring the t down. So plus t equals 360. And then I need to solve t. I need t to be by itself. Solve 14, excuse me. So subtract 216 from both sides. 216. Then t equals 360 minus 216, 144. So my t is 144 degrees. All right, so this is bringing it all back, including the algebra. This is the last chapter. You are going to use algebra a lot next year if you're moving on to algebra 2, because this all comes back. So this one's similar. It says, what's the value of u? This we did in chapter 5, this exact type of question. We've done it before. I'll still go through the steps. Hopefully at this point, you know what all 3 angles of a triangle add up to, and you can skip the formula. That would be my goal. If not, you have 3 sides of a triangle. You can plug it in, right? So S equals, 3 minus 2 times 180. That's 1 times 180, which is 180. You should all have known that. Then we did examples like this in chapter 5, so this should be somewhat of a review, adding everything that we have. Didn't I just change that to blue? Okay, whatever. So I'm adding 5u plus 106 plus 39 equals 180. We want to combine like terms, so I can add 106 and 39, and I get 145. Don't forget to bring down the 5u. And then 2 steps and I'm done. So subtract 145. Then I have 5u equals 35. The u is not by itself. I have to divide both sides by 5. And I get u equals 7. All right, so that's this whole lesson. So after this, I want you to go to G2 and complete that to 80%. I will say, be careful with the directions. So mine was nice and organized. I organized it so like questions were together. IXL will not be like that. You might have one question that looks like this guy, and then you might have one question that asks you to find the sum. Then you might have another question that asks you to find the sum. Then a question that asks you to find the triangle. So just be very careful. And as always, if you have any questions, please, please, please reach out via email or Remind. Thanks, guys.